Okay, so mixed molarity problems. Number one, mixed molarity problems. Okay, so it says 2.3 moles, 2.3 moles of sodium chloride, NaCl, in 0.45 liter of solution. Okay? So what we do is we're going to be using the equation molarity equals moles divided by liters. And it doesn't matter what is dissolved in. This could be water. This could be isopropyl alcohol. It could be methanol, ethanol. Ethanol is like drinking alcohol. It could be chloroform. It doesn't matter what it is. So all we concerned about is the mole quantity of the substance and how much liquid there is. Okay? So we are going to take molarity equals moles divided by liters. So we're going to say 2.3 moles divided by 0.45 liters. And the answer that the worksheet gets is 5.11 molar. And that is how you work out that problem. All right, any questions on that one? Are we good? All right, I guess I'll get a question in the pop-up box whenever we got questions. So I'll just keep going because you guys can always go back and rewatch this. Okay, number 2. It says that we have 1.2 moles of sodium sulfate, Na2SO4, in 12 milliliters of solution. Okay? So on this one, you're given the moles. So we still are using molarity equals moles divided by liters. You're given this. This is 1.2 moles. This one, though, is actually in milliliters. So how do we do that? We take 12 milliliters and we divide it by 1,000 because there are 1,000 milliliters in 1 liter. So what we do is we move the decimal place 3 places to the left. So I'm going to write that down. Move decimal 3 places to the left. So we're going to go 1, 2, 1, 2, 3. So I get 0.012 liters. And that's going to go on the bottom here. Okay, so if we rewrite this, we get molarity equals 1.2 mole divided by 0.012 liter. Okay, and the answer that we get here is 100 molar. That's a really, really high concentration and probably not possible. Never seen that high of a concentration. All right, so that's how you would solve that one. Number 3 is identical to number 2. So if you're trying to solve for number 3 is going to look like this. It's going to be molarity equals moles divided by liters, which is going to be 0.09 mole of lithium fluoride in 0.065 liter. We got that from taking 65 milliliters and dividing it by 1,000. Okay, so your answer here is going to be 1.3 molar. Morning, Han. All right, number 4. You guys can see the whole thing. That's cool. Let's scoot that up a little bit. There we go. Number 4. 120 grams. This one's going to be a little bit different because we have grams now. So molarity equals moles divided by liters. Remember with the mole quantity that moles is equal to grams divided by the molar mass of the substance. Okay, that's how we found moles earlier on this year, like in chapter 3, I think. right after we learned about accuracy and precision and things like that. So on this problem, you're given 240 milliliters divided by 1,000, and that's going to give you 0.240 liters. Okay, sorry about that. I will cut that part out. Okay, so what we're going to do in this one is we're going to take 120 grams of calcium nitrite, excuse me. So 120 grams of calcium nitrite. Now, how do I know the difference between nitrite and nitrate? This is nitrite. Nitrate is an extra oxygen, so that is nitrate. Okay?
Daddy.
Yes, ma'am. I'm shooting a live right now. Okay, then you go ask your mom. She'll make you some food before she leaves. Thank you. I know you guys know how this is, but you can't escape your own house. You know what I'm saying? Like, it's impossible. It's really, really impossible to escape your own house. Okay, so this is nitrite. All right, so calcium nitrite. So what we're going to have to do is we're going to have to find the molar mass of this. All right, so if you look on the periodic table, the molar mass of calcium is 40. The molar mass of 2 nitrogens is going to be 14.01. And the mass of 4 oxygens is going to be 16. Okay? So this is where we pull out our handy dandy calculator, or we ask the Google, because the Google never lies, right? So we do 40 plus 2 times 14 plus 4 times 16. I get 132. Okay? So this is 132 grams per mole. That number we're going to use here, and this number that was given in the problem, we're going to use that here. So we're going to take 120 divided by 132. Okay? So we take 120 divided by 132. 120 divided by the answer. That will give me 0.909, which is good. 0.90. We're looking at 2 sig figs, so 91. Okay? So 0.91 mole. And molarity equals 0.91 mole divided by the liter quantity, which is right here, 0.240 liter. So that's going to give me 0.91 divided by 0.240 equals 3.79. So we're going to add 2 sig figs, which would be 3.8. That says 37 grams, 240 mils. No, that is incorrect. It is not 37.5. It is 3.79 or 3.8 molar. Let me make sure I didn't mess the math up here. No. That answer on the worksheet right there, right here, that decimal place needs to be moved one place to the left. It should be 3.75 if that's the right answer. Morning, Miss Tanner. Okay. So if that is the answer that you got, then you probably didn't do it correctly, okay? So if you go back and you look at my actual work, it looks like they were off by a power of 10 whenever they solved for it. So this should be 120, right? And then to calculate the molar mass here, we're going to do calcium plus 2 of nitrogen plus 4 of oxygen. And that will give us 132. So it's going to be 120 divided by 132. And that's going to give us that 0.91. That goes here because it's moles divided by liters. And then we're going to take our liter quantity, put that on the bottom. So 0.91, let me do the math again, make sure I don't mess this up. So 0.91 divided by 0.240. And I get 3.79. Okay? Oh, you thought you did it wrong? No, you didn't do it wrong. No. And hey, sometimes, y'all, sometimes these worksheets are wrong, okay? That's why it's important that you actually go back and look at your work and make sure you did it correctly. Because whoever made this worksheet, and it wasn't anybody at our school. This was pulled online from somebody else in the department pulled it online, but I'm using it. But don't always trust those answers that they give you. Because if they mess something up and they publish this document, then that's the way it is. You got 3 point. That's perfect, Jonathan. Good job. Perfect. Yeah, and I rounded up. I got 3.78, but I rounded up because of sig figs, right? So we have our initial question was 120 and 240, and neither one had decimals. So the number 120 is 2 sig figs, and the number of 240 is also 2 sig figs. So that means your answer needs to be in 2 sig figs. Okay? Cool. Good job. All right. The rest of that entire worksheet, 5, 6, and 7, are all worked out the same way. So what I'm going to do now is I'm going to skip 5 through 9. I'm going to go to 10 and do 10, 11, and 12. Number 10 says, what is the concentration, meaning the molarity, okay? The word concentration, when we talk about that in terms of solutions, is identical. It's a synonym for the word molarity, okay? All right, so concentration and molarity are the same word. It says, what is the concentration of a 450 milliliter solution? So our L in the problem of molarity equals moles divided by liters is going to be 450 milliliters. But we have to have it in liters, so we have to divide by 1,000 or move your decimal 3 places less. So 0.450 liter. Okay? Oh, no problem, Jonathan. All right. Okay. The next thing says that it contains 200 grams of iron 2 chloride. Okay? So the mole quantity is going to be our grams divided by our molar mass. All right? And our grams divided by molar mass, our gram quantity is going to be 200 grams. And our molar mass of iron 2 chloride. So remember, iron is a 2 plus. And it tells us that because it says iron, and then the Roman numerals in the middle refer back to the charge on the original element. Okay? So Fe2 plus and Cl is a negative. We cross our charges. So we get Fe, Cl1 coming down. We don't write a 1 down. It's understood. Cl2. Okay. So if we have FeCl2, then this is what we're going to be using to calculate this molar mass. Okay. So if you look on the periodic table, and I don't have one out, so if I ever get one of these numbers wrong, tell me, but I'm pretty sure I'm right on these. This is 55.85, and we have 2 chlorines, so 2 Cl, and each Cl is going to be 35.453. Okay. Yes, I've memorized the numbers. So when we add these guys up, 55.85 plus 2 times 35.453, we get 126 and some change. So we get 126.756. Now I do get this question a lot. A question that I get a lot here is, do I use significant digits when I'm actually calculating my molar mass? The answer to that is always no. Okay? you don't mess with this number. So whatever number you get here, regardless of how many sig figs there are when you go to calculate it, this is the number that you're going to use as long as this number is larger than the given value. So since our given value up here is only 2 sig figs, this number has to be at least 3 sig figs to use it, okay? All right, so we're going to take this number, and this number is a number that's going to go here, okay? So we're going to say 126.756, okay? So we're going to divide these two, all right? So we're going to get 200 divided by the answer, and we get 1.57, okay? 1.577, so we're looking at 1.58 mole. All right? Now, the last step here is that we're going to go from the molarity, we're going to calculate the molarity, which is mole divided by liter. Here's your mole quantity, 1.58 mole, divided by your liter quantity, 0.450 liters. So you see how it's moles over liters? That is the definition of molarity. So what we do is we do 1.58 divided by 0.450 gives me 3.51. Okay? So my molarity is 3.51 molar of iron 2 chloride. Just like that. That's how you calculate it. All right. So here we go. So if we add all of these up, this is going to be our molar mass, which is going to go right here. Okay. So, whoa. Almost knocked that over. 3 times 40.08 plus 2 times 30.97 plus 8 times 16. I get 310.8 grams per mole of calcium phosphate. Okay, so that number is going to go right here. Okay, so we cancel out the grams, leaves you moles on top. Moles divided by liters gives you molarity. So we're going to do 660. Dang, got to quit using my head to hit the phone. 660 divided by 310.18 divided by 2.5. And I get 0.85. 851. Okay. So my molarity equals 0.851 molar calcium phosphate. Now, let me talk a little bit about what we would do with this particular set of information and what would this look like in an actual lab, okay? Good morning. I'm not sure you are. So how we'd actually use this information is, like, let's say we wanted to actually make a solution, okay? How do you make a solution? All right, how do you make a solution? By the way, I short solution to SOLN. So if you ever see SOLN in my notes, that's where I short it to. Reaction is another one of those because we get tired of writing that word out all the time, so we shorten that to RXN. Okay, not every teacher does that. Some teachers in college that I had at Texas Tech did that. My professors at UTA did that, but I've talked to other kids from other universities and they don't do that. So, but those are how I shorten things. Okay, because I hate writing stuff out. So, what do? Well, the first thing that we have to do is we have to know what concentration and how much we want. So for all intents and purposes, you are actually working this backwards. Okay? You're actually working this backwards. You're going to buy a MacBook, but your parents won't let you because of the virus. Well, it's not a computer virus. You can just order it off the Apple website. Just, when you get it, wipe it down or whatever. I do the same thing with my Amazon boxes. I mean, the virus is going to spread. It can live onto a surface for up to, I think it's 9 days, which is unheard of for a virus. The most dangerous part of a virus, though, is actually people spreading it, which is why people should be wearing masks. But they're not. I mean, they're choosing not to follow CDC procedure, which is ridiculous. I think people, because they can't actually see it, then they don't believe it, which is the common issue in biology and in chemistry because we're so abstract. Physics is the same way with particles. Since you can't see a particle, people freak out, be like, oh, there's not any particles passing through me. Yes, there are. They're called neutrinos. Neutrinos are always passing through all of us. It's bizarre. But if you're religious and you have faith, you have to have faith in science too, but you have to back up your faith with facts. So, know what concentration and how much we want. Okay? So once we know what the concentration is, let's say that we want a 6 molar solution of 300 milliliters of some compound. Okay? Let's say it's sulfuric acid. Okay? So once we know this information right here, we can then break it down to determine how much water do we need. If it dissolves in water, some things don't dissolve in water, especially organic chemicals. How much water do we need? How much solid are we dissolving? And that's where all the calculation stuff comes in. So this is the whole purpose right here for what you are doing. And for all intents and purposes, you work the problem backwards than what you would think. So you start at the end and work your way back to the front. Okay?